Hey again, everybody. So if you're seeing this, it means you've made it to the end of the tutorial. Congratulations, and thank you for sticking it out with us. I'm just going to be touching on a few sort of closing thoughts. So what's the use for us here, right? You've already seen how SQL can be useful. You've seen in practice what we use it for. But as academics, in like a broader sense, like why is this important to us, right? So I sort of, in my mind, break this up into two very broad categories. It might be the case that even as an academic, you find yourself collaborating with one of these like industry groups who have access to this really large, rich data set. If you are interested in something like sentiment on Twitter or Reddit, you could always do data scraping, but this is like it's far more efficient. It's far more clean if you could get access to the data that these groups are managing themselves. And if you find yourself in that situation, you're going to want to have some sort of experience with managing large data sets, right? And it's also just great to keep your employment options open, given the precarious job market that exists in academia that we all don't want to think about. Data is also just only getting larger as people integrate more like large language models and AI sort of collaborations in their work in a lot of different fields. That data is massive. You're probably going to be using SQL or a SQL-like language in order to like manage it and to work with it. And so having these skills sort of like gets you in on like the ground floor. It gives you like a little bit of a basis for you to expand upon later, depending upon what you need. And what we covered today, a lot of it would be considered sort of like beginner SQL. Advanced SQL users usually categorize things like extracting, inserting, and updating information in data tables as sort of beginner skills. Also using conditional filtering to pull out the information that you specifically need, and then joining multiple data tables together. These are all sort of like beginner SQL skills. What separates beginners from advanced are some of these things that are over on the right here. So integrating statistical concepts and softwares to analyze queried data. As researchers, we do this pretty frequently, whether it be t-tests, ANOVAs, regressions, multi-level models or mixed effects models. This is stuff that I think we all sort of a little bit more intuitively are comfortable with. And so we have like a little bit of a leg up, but where the divide exists is actually using the software to like combine these two things together, right? Katie went over that a little bit at the end, but there's still like a whole world of integration that exists that you should really familiarize yourself with if you wanted to go in this direction. One example that I wanted to just note that is built into SQL itself, so you wouldn't necessarily need R or Python or something else like that to use it, would be delta queries. So a delta query would allow you to make comparisons across a time series. If you wanted to query sales from this month and sales from last month and run an analysis to see how they've changed over time, you would be using a delta query, and that's something that's built right into SQL. Some other advanced SQL skills that you might want to familiarize yourself with would be creating common table expressions. So from our perspective, this would be something equivalent to like making a person level data frame based upon all the individual observations that you got from your participants, right? Common table expressions can be tables where you keep all of your scrap work or supplementary data that you're not necessarily really focusing on right now, but want to have access to later. And then other tools to make your querying more efficient. So these could include nested subqueries, wherein you are making queries in multiple tables at once. And the queries that you're making in those multiple tables are unique to each of those tables, so that you're not necessarily pulling in two tables, and then once you get those tables in, making more queries to cut out more data and more data and more data. You're being extremely precise about the data that you want from each table. And then indexing, which is partially the responsibility, as I understand it, of a server manager to make sure that the data is kept in a nice, tidy structure that everybody can understand and access. But it's also on the responsibility of the users to make sure that it sort of like stays in that structure, and that when they add new data to that table, that they are not messing up with that structure. So using indexing again to get exactly precisely what information we want from a table, and then using indexing again to add data to a very specific, precise space within that table is very important to like the health of a SQL server. And then lastly, I just wanted to like highlight a few resources that you can use if you did want to like go beyond this and build your SQL skills. So Katie had put in this Git repository resources, lists of commands and things like that that can really help you get started. If while you are sort of getting started, you find yourself a little bit stuck, there's the MySQL forums and documentation, which I think are very good. Please note that I think there are some slight deviations from like SQL iteration to like SQL not iteration, instantiation, from version to version, right? But for the most part, a lot of these commands are going to be pretty common across different versions of SQL. And then lastly, Microsoft actually has some really great SQL tutorials that you can access. Again, I know you guys cannot click on these links right now, but this PowerPoint file will be saved within the GitHub repository. So if you're not going to type this out, you can just go in there and click on the URL there. But regardless, thank you guys so much for joining us. I know it's probably been a very long day, but we look forward to seeing you next week.